Welcome to day 3 of our CNC e-course. Today we're going to cover CAD or Computer Aided Design. My name's Ivan Irons and I have a website called cncinformation.com. At any time you can go there and get some further information on CAD, but this is going to be kind of a general overview on Computer Aided Design. So let's go. Really, this is our 5-step CNC process here, and this is going to be the second one in that process, CAD. And really what we're doing is translating our design that we did in step 1 out of the 5. We're going to translate that design into the computer so we can manipulate it, resize it, and then also save it for later. This is that flow chart that we saw yesterday. And you'll just see we're moving down this flow chart. We're going to move to the CAD step next. So what does CAD stand for? It's Computer Aided Design. A lot of times you'll hear people call it Computer Aided Drafting as well. And that's very similar, but that's CADD, Computer Aided Design and Drafting. You'll hear that term as well. It was developed in the early 60s. So imagine when we started developing computers, people saw the potential to bring those into production, and they could be more exact and more precise when machining. Also, that was called NC, or numerical control, but also they saw how it could really help them out in their drafting to be more exact. And that's kind of where it showed up. It was developed to accurately describe those designs of parts, designs of machines, designs of assemblies. But they were after the blueprints or prints. You'll hear both those terms interchangeably. And really the dimensions. Before, all prints were hand-drawn, and as you can imagine, if every part on, say, a car, a vehicle of some sort, was hand-drawn, there maybe be a few errors since there's probably thousands and thousands of parts. And part of those are dimensional errors, so you could have someone building parts that were inaccurate, that would have to be remachined later just because the print was bad. So it was really to accurately describe those. If you've never seen a print, here's a good look at one. This is just a very simple collar. It has dimensions on it and multiple views here. So here's front, bottom, and top views in this one. So what are the different types of CAD? Well, there's 2D and 3D. 2D is two-dimensional. It's X and Y axes. 3D, you add the Z axis for depth. Now, 2D CAD is vector-based, and it's really, think of it like drafting system. And if you've ever taken drafting or were a part of a hand-drawn drafting class, 2D CAD and drafting are very, very similar. And you can make simple parts, we'll say. It's easier to use a 2D CAD as a crossover. Now 3D CAD, it's really the future, and you're getting into surface modeling and solid modeling, and you're describing that part in all of its detail. 2D CAD, maybe it's just a different view that you're describing. But 3D CAD, you're able to spin the part around, spin the assembly around, look at all the different angles of it. Here's a shot of 2D CAD. You'll see here's a few different views, but this is just a flat part. Not a whole lot to it, but you could draw this out on a piece of paper, and that's why it's 2D. There's X and Y axis. Here's a look at a 3D CAD shot. Now you'll see I just created this quick vase. This is in Rhino CAD. But you'll see you can spin that around. You can look at all the different angles of it. And this is really the future of where CAD's going. Now there's also another type, and it shows up more in CAM, which we'll talk about tomorrow, than it does in CAD, but it's called 2.5D. And it's prismatic. So that first 2D print that we looked at, all this does is give it some dimension or depth, or how thick the material is. But from time to time you'll see that on a software package, 2.5D. This is just a visual representation of that. Now there is kind of a design process if you're building a assembly or a group or a machine. You start out with these the part level down at the bottom, and you build various parts which merge together into a sub-assembly, which generally merge into groups, and then they go up to the machine level or completed. So imagine this just like in a car. That part level may be some parts in a differential, and the sub-assembly may be the differential, and then the group level could be the entire axle group with tires and wheels, everything on it, and then the machine level could be the actual car or truck going down the road. So there is kind of a design process or levels that go with CAD as well as you're designing. So CAD software packages, this is always interesting. A lot of them will be described as 2D or 3D. Any 3D program can do 2D, so that's kind of a differentiator there. But there's free packages out there that are absolutely zero cost, and then there's $10,000 packages out there and more. So kind of whatever you would want to spend. A lot of that money depends on the different design tools that it comes with and how well it keeps track of those different CAD design levels that we just looked at. And really the new thing is how, in say the last 5 years, is how does it integrate with other users? As you can imagine, you can have drafters and engineers in various levels designing and all working on the same project. So the high-end stuff today integrates between different users more than it ever has in the past. So you can do a group project versus individual and then merge them later. And just here I got a couple examples of different CAD software packages. There's Rhino, SolidWorks, AutoCAD, and a Libre. Those are just some of the popular ones that you'll run into. This is kind of the final photo here. This is an example, this is a screenshot off my computer of different tool palettes, and these happen to be Rhino CAM or Rhino CAD, I should say, tool palettes. And you'll see there's different ones there. There's dimensions that you can do. You can create solids, there's surfaces, curves, lines, circles, different layers. You can extrude things, there's meshes, there's just a whole host of different tools there. And this is probably, I want to say, a third to a half of the different tools that Rhino has inside of it. And this is really what you're paying for when you go to a CAD software program. How many tools does it offer you? How quickly and easily can you execute your design and get on to the next step? They're really after productivity here. And these are the differentiators between those software packages, the tooling that they offer. Well, tomorrow we go into CAM, or Computer Aided Manufacturing. So that's it for today. My name is Ivan Irons. If you have any other questions, you can go to cncinformation.com. Thanks.